Hey there, this is lesson 2.3 about how we can find the slope of a line and how will we be able to use slope to determine if lines are parallel or perpendicular. First, just a quick review for you about slope. Given the graph of a line, slope can either be described as the rise over the run or through the formula y2 minus y1 equals x2 minus x1. Using the pictures of the lines that you see here, we're going to just talk a little bit about rise over run. So when we talk about slope and we are referring to rise over run, rise is referring to the y values on our graph and how far up or down you must travel in order to get to the next point, which uses our y values. So on the first graph here, I'm going to start at this bottom point, which is at a y value of -1. And in order to travel to this second point that you see up here on my graph, I'm just going to move in an upward direction until I line up with that second point, which is going up 5. Since I'm moving upwards, it's a positive 5 as I move in a positive direction. Next, in order to get to my point, I'm going to move to the right 3 units. Again, since I am moving to the right in the direction of my positive values, that will be a positive 3. So if I wanted to describe my slope, which is abbreviated with the letter m, I would say that my slope is 5/3. Another way that you may choose to look at this is starting at the point at the very top, at the point 1,4. The other thing that I can do in order to calculate my slope is I can move down 5, and as I move down, my value becomes negative. I would then move to the left 3, and as I move to the left, I am also negative. So if I were to calculate my slope in that manner, m would be equal to -5/-3, and we know that 2 negatives make a positive, so I still come up with the same slope of 5/3. You can pause the video if you're interested and try the second example, see if you're able to calculate the slope. If you tried the second example along with us, you should have ended up with a slope of -1. Slope can naturally be found in the real world around you. There's 4 different types of slope that we will talk about in this class. The first type of slope is positive slope. So the first picture that you see is of the airplane taking off. This airplane has a positive slope as it increases up and to the right. My second picture is of the skier who is skiing downhill. This skier has a negative slope as he skis to the bottom of the mountain. Next we have the runner on the treadmill. This runner, as she just moves stationary and in a horizontal direction on her treadmill, this runner has no slope or a slope of 0. And finally, we have the bungee jumper who is about to take a fall vertically straight down off the cliff. This is an example of undefined slope. Next up, we're going to talk about how you can use the slope formula to find the slope between 2 points if you do not know what the graph of the line looks like. So we're going to talk about the formula that you see up at the top here. M, which is our abbreviation for slope, equals y2 minus y1 over x2 minus x1 as a method for finding the slope between 2 points. On your 2-3 skills practice, we're going to start with the first example. And what I'm going to do is I'm going to take the ordered pairs that they've given me. I'm just going to label those ordered pairs. My first ordered pair, we're going to call those values x1 and y1, and my second ordered pair I'll call x2 and y2. So now, following my formula from up top here, I'm going to take y2 minus y1 divided by x2 minus x1. And now I'll just solve this so that I get -8 over -2, which simplifies to a slope of +4. On the second problem, again, I'm going to go through and just label my ordered pairs. Something important to remember about when you are doing the slope formula, the y values always go at the top of the formula, because as we've talked about previously, slope is rise over run. Our rise needs to be on top. So we're going to have 0 minus 2 divided by 3 minus 0, which gives me a negative 2/3. Sometimes you'll get a fraction as an answer for your slope, and you will not be able to simplify that fraction, such as in this case, so we can leave our answer as negative 2/3. We always want to leave our slope as a fraction and not as a decimal. If you are able to reduce your fraction at all, you should always take advantage and reduce your fractions all the way. And for our last problem, we're going to have 6 minus 9 over 0 minus 1, which gives me negative 3 over negative 1, which simplifies to a positive 3. Okay, further down on your 2-3 skills practice page, we're going to look at example number 10 and 11 together. On this page, we are given an ordered pair, and we're given the slope of the line. So we're going to come up with the graph for this line using our slope, and keeping in mind that slope is always going to be found using our rise over run. So I'm going to begin first by plotting the ordered pair that they've given to me, 0, 4. And I have a slope of positive 1. Okay, I'm going to pretend that if this were to be made into a fraction, that there is an imaginary 1 in the denominator of that fraction. That means I'm going to be moving up 1 and to the right 1, since both of these values are positive, in order to get the next point on my graph. So using 0, 4 as the place where I left off, I'm going to move up 1 and to the right 1 to get my next ordered pair. And I'll do that one more time, up 1 and to the right 1. I can also go back to my original starting point, and I can reverse this and also go down 1 and to the left 1. Connecting all 4 of my points together to make my straight line. On problem number 11, again, I'll begin with the ordered pair that they've given to me. I'm going to move over 2 and down 4. I again have a whole number. I have an integer as my slope. So I'm going to put a 1 in the denominator to make it into a fraction. This time my numerator is negative. That means I'm going to be moving down 1. And my denominator is still positive, so I'll move to the right 1 in order to get the next point on my line. So again, I'm moving down 1 to the right 1. And I'll do that again, down 1 and to the right 1. And again, I can reverse this to get more points on my line. Since I ran out of room on the coordinate plane, I'm also going to go up 1 and to the left 1. Connecting all 4 of my points together. Excuse my very crooked line. And there's my graph. The next thing we'll talk about in this section is the difference between parallel and perpendicular lines. If you remember from geometry, parallel lines are 2 lines that will never intersect. The reason why parallel lines will never intersect is because they have the same slope, which keeps them from crossing. Perpendicular lines, on the other hand, are 2 lines that intersect, and when they do, they make a 90-degree angle. That's what's special about perpendicular lines. In order to make that 90-degree angle upon intersection, the slope of perpendicular lines are opposite reciprocals. Opposite meaning their signs are different from one another. So one line would have positive slope while the second has negative slope. And reciprocal is when we take a fraction and we flip it upside down. So let's take a look at some examples of how we can go back and forth between parallel and perpendicular slopes. In this first problem here, I'm given a slope of -1/2. So if I were to write the slope of a line parallel to a line with -1/2 as their slope, I wouldn't have to change anything about that slope because parallel lines have the same slope. However, if I were going to write an equation for a line that was perpendicular to the slope over here of negative 1/2, I am going to take the reciprocal, so flipping negative 1/2 upside down would turn it just into 2, and I'm going to make it a positive 2 since my original problem was negative. The next example, my slope that I'm given is 5. So slope of a line parallel to this would also be 5. Slope of a line perpendicular to what I've been given, the reciprocal of 5 is 1/5. And I'm just going to make that negative so that they have opposite sides. If you're interested, you can pause the video right now and practice converting slopes between between parallel and perpendicular lines. And when you play the video again, you can check out your answers. Once you've finished watching the video, you're going to want to finish your 2-3 worksheet, including number 14, 15, and the word problem at the very end, number 16, from your 2-3 worksheet.